Eduauraa, सपनों की
Give me freedom.
Hi students, I'm Sandeep Jain, your maths mentor, and we'll be having fun with numbers today. Now students, will look at operations on real numbers. The following rules will apply. The sum or difference of a rational and an irrational number is irrational. So rational plus irrational, irrational, rational minus irrational is irrational. The product or quotient of a non-zero rational number with an irrational number is irrational. So 3 into root 2, rational into irrational is 3 root 2, which is irrational. Addition, subtraction, multiplication or division of two irrationals may be rational or irrational. So if you have root 2 upon root 2, you have 1. Root 2 is irrational, root 2 is irrational, but 1 is rational. So nothing can be said, students, about the product, the ratio, sum and difference of two irrational numbers. You can have root 2 minus root 2, you add them, you get a 0, which is rational. And remember students, to rationalize the denominator of 1 upon root a plus b, we multiply the numerator and denominator by root a minus b, so that the denominator will be a minus b square and you will have a root a minus b in the numerator. Look at some theorem, students. Suppose x equal to p by q is a rational number such that the prime factorization of q is of the form 2 to the power n into 5 to the power m. Understand this, the denominator q, only 2 and 5 are there in the prime factorization. N, m are non-negative integers. Then I say that x has a decimal expansion which terminates. That means if you express x in decimal form, you will always get a terminating form. The digits will terminate at a certain point. The next theorem, x equals p by q is a rational number. Now the prime factorization of q is not of the form 2 power n 5 power m. That means there are some other factors besides 2 and 5 which are there, n, m are non-negative integers. Then I'll conclude that x has a decimal expansion which is non-terminating, repeating or recurring. That means if such a pattern is observed, the number will be rational, all right, but when you express it in decimal form, you will get patterns like 1 by 3, 0.3333 and so on. The digits will repeat and recur. Third theorem, square root of 2 is irrational. We'll have a proof of this. So we'll prove this by contradiction. Assume that root 2 is rational. Let's say root 2 is rational. We'll arrive at a contradiction. So what do you mean by rational? There will exist r and s not equal to 0 such that root 2 is r upon s. Suppose r and s have a common factor other than 1. Then we divide by that common factor to get root 2 is a by b, where a and b are co-prime. So root 2b is a. Now square both sides, rearrange, I get 2b square is equal to a square. So this means that 2 divides a square. Now we know that if 2 divides a square, it will divide a. So I write a as 2c for some other c. Substituting this in the equation, I get 2b square is equal to 4c square. That's b square is 2c square. So 2 divides b square. So 2 divides b. There's the catch. A and b have at least 2 as a common factor. which is a contradiction. Initially we said that A and B should not have a common factor. So this contradicts with the fact that A and B had no common factor other than 1. So there is a contradiction with our assumption, and we will conclude that root 2 is not rational.